Hello everyone, today we'll explore the derivatives of exponential functions, find the derivative of logarithmic functions, and use logarithmic differentiation to determine the derivative of a function. So let's look at the theorem. Let e of x equals e to the x be the natural exponential function, then e prime of x is equal to e to the x. In general, d dx of e to the gx is equal to e to the x times g prime of x. This means here, if we have e raised to some function, let's call the function stuff, e to the stuff, the derivative of e to the stuff equals e to the stuff times the derivative of stuff. So whatever that function is, take that derivative times e to whatever that function is, and that is your derivative. So it's a chain rule idea. Okay. Find the derivative of f of x is equal to e raised to the tan of x. So f of x equals to e raised to the tan of x. D dx of e to the tan of x. Again, if our stuff is tan of x, so e to the stuff is e to the tan of x is equal to e to the tan of x times the derivative of tan of x, right? And know that the derivative of tan of x is equal to secant squared x, so that would be e to the tan of x times secant squared x. So let's note that. So that would be equal to e tan of x times secant squared x, and we're done. Okay. Now let's look at another problem. F of x is equal to e to the x cubed minus 2x plus 3. What's the derivative of that? So then remember, derivative of e to the x cubed minus 2x plus 3 equals e to whatever the function is times the derivative of the function. So that is e to the x cubed minus 2x plus 3 times the derivative of x cubed minus 2x plus 3. And so that would be equal to e to the x cubed minus 2x plus 3 times 3x squared minus 2. Since 3x squared minus 2 is a coefficient, we can bring that in front of the e. That's our final answer. So that's 3x squared minus 2 times e to the x cubed minus 2x plus 3, and we're done. Okay, now let's look at another problem. Our function was e to the x divided by x minus 2, all in parentheses. Then again, we're using e to the stuff times the derivative of stuff. So that would be e to the parentheses x over x minus 2, parentheses d dx of x over x minus 2. Use our quotient rule for the derivative of x over x minus 2. So it becomes e to the x over x minus 2 times low d high minus high d low over low squared. So that's x minus 2 times 1 minus x times 1 over x minus 2 squared, and we try to simplify that as much as we possibly can. So that's e to the x over x minus 2 over x minus 2 minus x over x minus 2 squared, and we can take that one more step down. E to the x over x minus 2 times negative 2 over x minus 2 all squared. And finally, bring our coefficient in front of the e. So that's negative 2 over x minus 2 all squared times e raised to the x over x minus 2. And we're done. Alrighty. It's another way of dealing with that. Now let's look at another theorem. The theorem of the derivative of the natural logarithmic function. If x is greater than 0 and y is equal to ln of x, then dy dx is equal to 1 over x. More generally, if h of x is equal to ln of the g of x, then h prime of x is equal to 1 over g of x times g prime of x. Okay, let's use this idea to differentiate. F of x is equal to 3e to the x plus 10x cubed times ln of x. So here we have a problem. F of x is equal to 3e to the x plus 10x cubed times ln of x. Let's find f prime of x. F prime of x, the derivative of 3e to the x, that's simply going to be 3e to the x because it's a coefficient, and the derivative of e to the x is just e to the x times 3, which is our coefficient. So that doesn't change. Plus 10. The x cubed times ln x, we have to see that as a product, so we apply the product rule. So that is the first times the derivative of the second, which is x cubed d dx ln of x, plus the second, which is ln x, times the derivative of the first, which is the derivative of x cubed. Our next step, we find the derivative of ln of x, which is 1 over x, the derivative of x cubed, which is 3x squared. Bring everything else down. Then we search for like terms and simplify. While we are simplifying, x cubed times 1 over x is x squared, plus ln of x times 3x squared a common factor. So we can try to pull common factors out. And so this stage, we're just trying to simplify as much as possible. And that will be equal to 3e to the x plus 10x squared, 1 plus 3 ln of x. And we're done. Let's look at another theorem. The theorem, the derivative of the general logarithmic and exponential functions. If y is equal to log base b of x, then dy dx is equal to 1 over x ln of b. More generally, if h of x is equal to log b of the g of x, then h prime of x will be equal to g prime of x over g of x ln of b. And so this is like a chain rule idea right here, where because we have a function here instead of just x, then we also have to take the derivative of the function. So that gives us our g prime of x right here. So it multiply by the derivative of the function g of x, which gives you g prime of x. Okay, number 2, if y is equal to b raised to the x, then dy dx will be equal to b raised to the x ln of b. So it's the same b to the x, but multiplied by ln of b. More generally, if h of x is equal to d to the g of x, then h prime of x will be equal to b to the g of x times g prime of x ln of b. So because this is a function, the chain rule idea here comes in where you have to take the derivative of your function in the exponent. Okay, let's apply this to a couple of problems. Differentiate h of x is equal to 3 raised to the x over 3 raised to the x plus 2. Okay, so here's our problem. H of x is equal to 3 raised to the x over 3 raised to the x plus 2. We see that as a quotient, so we can apply our quotient rule right here. The quotient rule says low d high minus high d low all over low squared. So it'd be 3 to the x plus 2 d dx 3 to the x minus 3 to the x d dx of 3 to the x plus 2 all over 3 to the x plus 2 all squared. Okay, so let's continue doing that. Now, what we can do, we take the derivative of 3 to the x. It's going to be 3 to the x ln 3. We take the derivative of 3 to the x plus 2. That's still 3 to the x ln 3. Based on our rules for our logs differentiation that we just learned. So we have 3 to the x plus 2 times 3 to the x ln 3 minus 3 to the x times 3 to the x ln 3. What we can do in this step is that we can distribute 3 to the x times 3 to the x ln 3, and then plus 2 times 3 to the x ln 3, expand it out a little bit. So in this step, we have 3 to the x times 3 to the x ln 3 plus 2 times 3 to the x ln 3 minus 3 to the x times 3 to the x ln 3. Notice there's a 3 to the x ln 3 and 3 to the x ln 3 right here. So they can, because they have opposite signs, they will cancel each other out. So we're left with 2 times 3 to the x ln 3 over 3 to the x plus 2 all squared. Let's talk about logarithmic differentiation. Sometimes in order to differentiate some more complicated equations, we can use a strategy called logarithmic differentiation. The steps are, given y is equal to h of x, 1, take the natural log of both sides to get ln of y is equal to ln of hx. Use properties of logarithms to expand ln of h to the x, h of x, as much as possible. Differentiate both sides. On the left, we'll have 1 over y dy dx, then multiply both sides of the equation by y to solve for dy dx, and then finally replace y by h of x. Let's apply this to a problem. Y is equal to 2x raised to the 4th plus 1 all raised to the tan of x. Now this is a good candidate for logarithmic differentiation. Apply ln to both sides. Ln of y is equal to ln 2 to the x 2x to the 4 plus 1 raised to the tan of x. And so the ln of y will be equal to, use the property of log to bring tan of x over, so tan of x times ln of 2x plus 4 by the power property. Then we can take derivatives, so dy dx, so that's 1 over y dy dx is equal to tan of x, d dx ln of 2x plus 4, plus, using the addition law, ln of 2x plus 4 d dx tan of x. And then if you multiply both sides by y times 1 over y dy dx is equal to tan of x, 1 over 2x plus 4 times 8x cubed after you take the derivative, log the derivative on this side, plus ln of 2x plus 4 times secant squared x all times y. And then you have y on this side times 8x cubed, 2x plus 4 tan of x plus secant squared x, ln of 2x squared plus 1. And then finally replace y. So dy dx will be equal to 2x raised to the 4 plus 1 tan of x all times 8x cubed over 2x plus 4 tan of x plus secant squared x ln of 2x to the 4th plus 1. And that is our final answer. Notice in our final answer, we always replace our y. So there will be no y's in our final answer because we take the original explicit different